topics which we have to cover in this unit are introduction, occurrence of metals, from where the metals occur, the concentration of ores, extraction of crude metal from concentrated ore, then we have refining, and then thermodynamic principles of metallurgy. After this we have a Lingam diagram, and the last we have to study about the extraction of various elements like aluminium, copper, zinc and iron. So elements, you must have studied in your junior classes also what are elements. See, elements are the atoms. Elements are actually where the atoms, where in which the same type of atoms are present, right? Elements in which same types of atoms are present. We have non-metals, we have metals, and we have metalloids. This whole chapter is all about metals, and we know metals exist in two states. One is free state, like we have silver, gold, yes, platinum, free state. But atom or elementals also exist in combined state. In combined state, like we have ZnS, that is zinc blend. Then we have corundum, like Al2O3, or aluminum. Its ore is called as corundum. Next we have metallurgy terms. So here this chapter is all about metallurgy, right? Now before going to metallurgy, we should know what are the metallurgy terms that we have to discuss in this chapter. The first thing that we have to discuss is about minerals. What are minerals? You must have studied about minerals in your junior classes also, especially in geography, ores. And the last which we have to discuss is gangue. So we will discuss each of the terms one by one. So we have to discuss each of the term one by one. Mineral. What are minerals? See, the compounds of metal, they occur in nature along with the rocky and other impurities. These are called as minerals. Means, suppose we have a rock. And suppose we have iron metal in it. So if we take a magnet near to this rock, and if attraction properties are visible, then we'll guess that yes, iron metal is present. And this metal will show attraction properties. So we'll know that iron is present. The compounds of metal occur in nature along with the rocky and other impurities. This is called as minerals. Next we have ores. Now what are ores? See, the minerals from which a metal can be extracted commercially or profitably is called ore. Means ore is actually that mineral which can give us a metal that can be extracted commercially or profitably. For example, if we have, like, suppose, how will you understand this? Suppose we have two minerals of iron, suppose 60% and 70%. These are the two minerals of iron. Now I know that the percentage of iron is more in this, but if you go and try to extract the iron from this method, the process of extraction from this will be expensive, but from this it will be cheap. So we have to see not only the percentage but also that the metal that we have to extract from that ore, it should be profitable. So this 60% metal, this will be called as the ore. This is called as ore. I hope this is clear to you. Next we have gangue. Now what is gangue? See, the impurities present in metal ore or earthly impurities like sand and soil, these are called as gangue. Like we know that in mineral, only metal is not present. There are some impurities also, sand, clay, soil, right? So these impurities are called as gangue. Now this is our minerals of iron. We'll do one thing, like I have told you, we have to study about the extraction of different elements or different metals. So while doing the extraction, we will discuss about minerals of all the metals. So better here that we should discuss about these minerals later, in the later stage. Next, let's try to understand what is metallurgy. See, what is metallurgy? The process of extraction of a pure metal from its ore is called metallurgy. What is metallurgy? The process of extraction of pure metal from its ore is known as metallurgy. Means, like suppose we have an ore and from the ore we have to do the extraction process. We have to do the extraction process. So from this ore we'll get our metal, we'll get a pure metal, plus we will also get some impurities. Next we have, see, the main topic, the main chapter starts from here. Extraction and isolation of metals involve the following major steps. So what are the major steps? Number one is the concentration of the ore. Then we have reduction of the ore, and third is refining. So from concentration to reduction, in the reduction step we get around 97% of metal, but still there are some impurities present. So what we will do is we will do the refining, and after refining we'll get 99.9% pure metal. Is this clear? We'll get 99.9% pure metal. Next, so we have discussed each of these steps one by one. First step is the concentration of the ore, and we also call it ore dressing or benefaction. Concentration of the ore is ore dressing or benefaction. These are the other two names. So this method is used for the removal of the unwanted materials like sand and clay. As I have told you earlier also that some impurities are present, so we have to remove these impurities. So the removal of this impurities is called as concentration of ore, and the process of removal of gangue from the ore is called as concentration of ore. Next we have, now we have to study the different types of processes involved in concentration of ore. The first type is hydraulic washing. Now what happens? Let us quickly read out the points and then we'll try to understand what is hydraulic washing. See, this method, it's basically used for heavier elements or heavier metals like tin, lead, iron. And this method, it's based on the gravity separation. Gravity separation means heavier metals. We know that heavier metals, they will feel more gravitational force, so they will settle down at the bottom. And the lighter gangue particles, they are washed away, and heavier ones are left behind. Means the lighter particles, they will remain on the surface, so they will wash away. They will get washed away with the water. But because the heavier elements, the heavier metals, they're heavy in size, so they settle down at the bottom. So we have this. We have crushed ore, right? We have this crushed ore. Now what happens when initially we have to do the grinding and crushing of the ore. Then what happens? This crushed ore, this passes through this water. The crushed ore passes through this water. Now what happens? Because we know that the gangue particles, they are lighter in weight, so they will remain at the surface and they'll get washed away with water. So we will get gangue with water, with impurities with water. But here, can you see this sloping table? So what happens, since the heavier elements, they are like this size, they're heavier in nature, so what happens, they will settle down at the bottom. Next we have magnetic separation. Now what happens in magnetic separation? See, used if one of the ore or impurity is magnetic in nature. We use this process when one of the ore or impurity is magnetic in nature, right? So magnetic particles, they are attracted and they fall near the magnetic roller, while non-magnetic particles, they fall away from the roller. So what we have to do, see, this is a magnetic roller, right? Can you see this magnetic roller? So what happens, we have to, I've told we do the crushing, we have to do the crushing, we have to grind the ore. So what happens, whether the impurity or the ore, if it's attracted to the, if it's attracted towards the magnet, so it will remain on the surface, and so therefore it will fall on this, in this beaker, because it is attracted towards magnet, and that particles which are not attracted towards particle, they will fall away from the roller, and we'll get non-magnetic particles here in the left beaker, and we'll get magnetic particles in the right beaker. So you must have an idea about the applications of these methods. Now third, next we have froth flotation process. This is a very important process. Now these method, froth flotation method, it is only used, it's used for the sulfide ores. It is used only for the sulfide ores of copper, zinc, lead and iron. So you have to remember that we use froth flotation process for the sulfide ores only, and you also have to remember the names, like copper glans, we have lead sulfide, its name is galena. You have to remember the name, because sometimes they simply ask you the name. Then we have ZnS, its name is zinc blende. Then we have, at the end we have FeS2, iron pyrite. Now sulfide ores, they are wetted by oil. These sulfide ores, they are wetted by oil, and you have to remember these sulfide ores, they are wetted by oil and they move upward in the form of froth, whereas the gangue particles, they are wetted by water, so they settle down at the bottom. Can you see this process, froth flotation process? Now what happens in this process is, like we are adding, can you see this pulp of ore and oil into this process? Now what happens, we are adding this pulp of ore and oil. Now what happens, we are actually, this is a rotating paddle and air gets entered from this rotating paddle. Now we are rotating this pedal quickly. The rotation is going on so fastly that what happens, that there is a formation of froth, and we know that the water particles, they will settle down, and the formation of froth, as I've told you, the sulfide ores, the mineral ores, because we are using sulfide ores only here. So mineral ores, they are wetted by only oil, and we know that oil is lighter, or you can say less dense than water. So oil particles, they will come, mineral particles, they will come in the form of froth, whereas water particles, they will settle down, and inside the water we have gangue particles, you can say impurities, and from this we can easily collect the froth, right? We can easily collect the froth and gangue particles. In the gangue particles we have, in the water particles we have impurities present. Next we have, see, main parameters you have to study. What are the main parameters of froth flotation process? So here we have to use frothers like pine oil, eucalyptus oil. Why? Because we know that the ore is only soluble in oil. Collector, we have to use potassium ethyl xanthate to enhance the known wettability of the mineral particles. We know that mineral particles, they they do not get wetted by water, but we have to enhance the non-wettability so that even on dilution, it never gets diluted by, it never gets wetted by water. Froth stabilizer, because we know froth has formed, and after some time froth is not that much stable, so and it gets dissolved. So just because, but we know mineral particles, mineral ores, they are present inside the froth, so we have to stabilize our froth. So we add phenol and cresol. Last is depressant. Now what is this depressant? Used when a mixture of sulfide ore is present. Whenever we are using a mixture of sulfide ore, we have to add some depressant. For example, we have a mixture of lead sulfide plus zinc sulfide. We have this mixture, right? Now if we add NaCN in this mixture, what will happen? This PBS will not react with NaCN, but this zinc sulfide will react with NaCl to form a water soluble compound, that is sodium. You don't have to learn it's okay, you don't have to learn its name for now, because we have not done coordination chemistry till now. Since this is water soluble, yes, so it will go with the Kang particles, yes, and in the froth we will get lead sulfide particles, right? So this is how we use NaCN. We have to add NaCN as a depressant when a mixture of sulfide ore is present. Next we have the last process of concentrated ore is leaching. Now what is this process, leaching? What happens in this case? When a metal is more soluble, then impurities present in its ore. You have to remember the application when we have to use leaching. When metal it's more soluble, we mainly use leaching for silver and gold. Now what happens in this leaching process? Suppose we have silver sulfide, the sulfide of silver, it's called as argentite. You should know its name, argentite. Now what happens? Suppose if we add NaCN and oxygen to it, what will happen? We'll get a complex. The silver will come into this complex and we will get 4 moles of Na2S. But we want our metal back. So now what happens? This complex, the zinc, we will use zinc for this is step 1. And this is step 2. So we have to use zinc for the reduction to get our metal back, and Na2ZnCnO4. This is the complex which will be formed. This is the process of leaching. I hope this process is clear to you.